so now we are going through the fifth thing, and that is integration by parts. I've underlined it for you here. Integration by parts. That is what we are doing. And this is beautiful because this is going to be the reverse of product rule in differentiation, okay? Now, how are we going to be dealing with this, okay? Because we've talked about how we have this x squared guy, and we've seen the situations in which you can find him, okay? We've seen that you can find him when you're doing this ln x guy, and we say that it's easy to see because this x squared will be there, and then there's something else, whatever, that you can convert into squared by taking square root of. And now, what we're saying is, we had another situation, of course, where we had this x squared being there again, but we say this one is easy because the top will be the derivative of the bottom. The top will be the derivative of the bottom. Now, there is one, and this in here, we talked about how there's an addition sign, and here you can see that the top is the derivative of the bottom. We don't care about the sign. But on here by partial fractions, we saw that you can still get another x squared in the denominator. You can get a fraction, but we saw that there was a minus sign, so we cannot use this. Okay, we can't, not even possible. Because if you look at the example, that we can be able to use this idea of ln x, then there has to be a plus. Now, we've talked about fractions. So fractions, like similar to quotient rule, we've covered that. You should be fine. If you're not sure, you can go back and check the situations that we've talked about, and you should be able to do it. Now, we are here at by parts. Now, by parts is going to be the reverse of product rule. Product rule is what we use when we have two things multiplying and we want to differentiate. Now, we want to see what do we do when we have two things multiplying and we want to integrate. There is USAP, which we talked about, but these things will be related. Now, in here, we have by parts. Now, by parts, you'll be having two things multiplying, and these two things will be functions. There will be functions, and these two functions will be of different nature. So, this is the word which we are going to use many times. It tells you two things. Number one, the types of functions which you're going to be dealing with. And number two, the order in which you're going to choose u, because integration by parts is going to be, we're going to make use of a formula. So we have to use it. So we are going to use LEPET, okay? This is exactly what we are going to be using, this acronym, LEPET. L stands for, these are the types of functions, and this also tells you the order in which you're going to choose your u. I'm going to talk about it just now. So let's first talk about the types of functions that we're going to work with. What is L representing? This is logarithmic, okay? This L represents logarithmic functions, okay? And examples, ln x, okay? That's the one which you deal with at this age, this level. So ln x is going to be a logarithmic function, okay? What makes it a function? If we want to put it as a function, you can even say y is equal to ln x, okay? But when we just have something ln x, that's a function. Even f of x is equal to ln x, that's a function. So now inverse trig, for inverse trig, we have sine inverse of x, okay? And cos inverse of x, and tan inverse of x. Although we know that sine and cos don't come, the only one which we have is tan inverse of x. That's the only one which we have in this situation. But it just is for the inverse trig. So this is inverse trig, okay? Should write that. This is, let me write it in white. Inverse trig. And the inverse trig is going to be tan inverse of x. Not hard, right? Not hard. Then P is going to be the polynomial functions. Polynomial functions, yes. Oh, everybody should be good at this. Poly, many, number. Nomial means numbers. So this is something with several terms. X squared plus 5x minus 7. That's a polynomial. Okay. X cubed. That's a polynomial. 7 is a polynomial. Negative x. That's a polynomial. Okay. Now, these are all polynomial functions. Now we have the E, it's representing exponential functions, okay? Exponential functions, okay? We know that it's exponential functions. You can put the word functions. I was not putting the word functions, but these are all functions. Here, exponential functions, it is when you have x as a power. So very common one is e to the x, okay? What makes it exponential is not the e, it's the power. X is a power. Exponent means power, okay? The power is the exponent, okay? It's the same word, okay? You can call it the exponent or the power, or you can call it the index. When there are many, they're called indices. That's the same thing. So, and we can have it like 7 to the x, whatever. These are exponents, and these are exponential functions. Then the last we have trig. trig functions, okay? Trig functions. And what would we have in trig functions? 6 guys. Sine x, cos x, okay? Tan x, then cosec x, or let's start with sec x, okay? Then cosec x, and then cot x. These 6 are all functions. Here we have they're all trig functions. So now when we do by parts, what happens is you are going to have one function of each type multiplying the other of another type. So it's like logarithmic times trig, or logarithmic times polynomial, or whatever. These functions are going to meet, and you are trying to integrate. Remember, you'll be trying to integrate. And they'll be multiplying. So here are examples they've given you in the syllabus. Look at this. Integration of this. So integration of x sine 2x, okay? Sine 2x is a trig function, right? And it's multiplying x. What is x? It's a polynomial. We said it's a polynomial. Okay, you can have it even here on polynomials. You can have x. So these are polynomials. When you just have an x and whatever, these are polynomials. And then here we have sine x, which is our trig. And we are trying to integrate with respect to x. You are going to use by parts. So in this first one, we are mastering where we use this. And it is when you have 2 different types of functions multiplying. When I have 2 different types of functions multiplying and I'm asked to integrate, then the method I use is by parts. So you should be able to look at the question, see what you've been given. If the moment you realize, you watch, you see this, then straight, look at this. X times e to, so x squared e to the negative x with respect to x, okay? This x squared is a polynomial. E to the negative x is an exponential. We are asked to integrate. So this is again a by parts question. Okay, if you look again here, ln x, ln x is a special guy. Should know that ln x is going to be by parts, because when we integrate him, we change him to be 1 ln x, okay? So there is 1 ln x with respect to x. And numbers are polynomials. If you've seen, we put 7 as a polynomial there. So 1 is a polynomial, and then ln x is a logarithmic function. So because of that, we have to use by parts. You see, there are 2 different types of multiplying. That's what we do when we want to integrate ln x. Now here we have x tan inverse of x. Of course, it's by parts. Of course, integration of x tan inverse of x. Of course, because x is a polynomial, tan inverse is an inverse trig. So there we go. That is it. These are the situations. Once you see it, we have to use by parts. Now we're going to go to the next video where we learn what it says. What does the by part formula say? And we do several examples. All these ones that you see in the syllabus, and we'll see how it goes from there. Goodbye for now.